All right, my friends, I have to interject this because this is really needs to be talked about. Right now, the channel has about 200,000 subscribers, and really there's not that many hits on it because they don't advertise my channel because I'm not within the mainstream. That's my opinion. I could be wrong, but all of this stuff, as I showed you, is just not right in the mainstream versus what Roger's stream is. This is absolutely, certainly, no question whatsoever in my mind, authentic, and all of those fibers which are deep inside the skull, nobody could have put them there. Nobody would know he put them there. And the lip is all twisted back because he was laying on his nose. And the back of the brain is pushed up forward, and this one isn't. This is a guy's, brain scan. And he was laying there on his face. And this is all crystal because I know I explained this. I certainly explained it in the last video, and I think I explained it in this one. It's nucleophilic invasion and substitution. However, the fibers of the keratinized stuff, the keragens, collagens, they don't change like the gooey stuff in your body. Even like your flesh changes very much different. So bone changes very, very different. And any fluid stuff changes very different. This is the coating on every single fiber, and it stays. You can see it. You see it? There it is right there. Same stuff. No difference. Absolutely identical. Except the head was on his face, so this drifted down. And the nose lifted up. And because it was in the mud. Now, the same thing happened with mine, only it wasn't in a crystal situation, but it was on its back like this. And that's what created this to be different than the top. Although I'm telling you, this thing is really, that just blew my mind. But when I realized what it is what it is. All you can do is try to determine what's reality and what isn't, even though reality might be much more strange than the biggest thing of fiction you've ever seen. And it is. And it absolutely is. It's extremely bigger than anything you could ever possibly have imagined. And it was all written about in these ancient texts. This is what blows my mind. Now, we are going to go in with the microscope and start looking at all of the things that we can look at as best we can. Talk about them. Go back through some of the ancient texts. We're going to look at all of these different rocks again under the microscope. And just discuss what the chemistry is and, just sort of have a ramble. Because I think I've shown enough. For the average person, if they put any time into it, they realize this is not a joke. This is real. This is absolutely 100% certainty, no question whatsoever. And this lung right here would be about the size of a lung that would be for maybe my 3 foot wide hand guy. The other one would be much bigger lung. And like I say, the hair follicle right there is this big. And that would be, he'd be about the right size, about 200 feet tall, to have a hair follicle this size. I thought it would be much, much bigger to have a hair follicle this size, but when I did the math, I think I'm right, that it would be about 200 feet tall if it was a human and had this would be a hair follicle. So, let's get into the microscope. Okay, don't forget, this is the lung, this is the surface, and this is like one of the lobes of the lung, and those are little alveoli holes. And this is the guy's chest with the lung embedded. This is his back ribs, or his backbone, whatever you want to call it. And these are little chunks of his bone. And again, this appears to me that this guy died on top of the black cap, which the other ones I have died in the midst of it and were laying flat to me somewhere. It's hard to say, but I think this guy died on top of the black cap. I think the other ones I have died in the midst of the red bed and the gray clay. But at any rate, we're going to be looking at this alveoli here in the microscope up above up here. And it's going to take me a minute to get it focused in. We're going to have to turn the lights on. I'm going to show you one thing, the difference between, hold on a second. Okay, this is the surface of the lung. These are little cavities and so forth, and this is the fabric of the lung. Now I'm going to play a couple little tricks on here so that you should be able to see this, hopefully a little better. I'm going to highlight this from the side with a little light so you can see those are cavities. You see them? Those are cavities. Now how big are they? Well, let's see if we can see how big they are. Whoops. This is a little pinpoint, basically. It's a little spike that I used to dig things out with. You see how big it is compared to the little alveoli? So they're not big, but they're not tiny either. Some of them are very tiny. This thing just barely fits in. Some of them are much bigger. It's a variety. Now, I'm going to show you something, the difference between dry and wet. Right now it's dry. Just hold on a second. Alright, this is now the lung tissue as it's drying out. And they dry pretty quick. I'm going to just swish it around a little bit to make sure it's nice and clean. This is a toothbrush. I have another one I usually use for my teeth. Now, this is what we're looking at now is we're getting a little bit better color because of the wetness of it. You see down there, that little tiny hole right there is where the air goes down. And they'll basically all have them. And if you come off the edge here, you get into that muddy stuff. This is the muddy stuff right here. Let me turn that light off. Now, I'm going to come right down on that muddy surface. So don't forget, over here was where the lung tissue was bubbled up in all those little holes. Now, right here is nothing but mud. And mud is nothing but flesh. Alright, this is going to take a minute to dry up. Let me get it dried up. Hold on. Alright, so here we are in the lung. Now we're going to move out into the mud. Alright, did you see what I did? I came away from here slowly and moved over here into the mud. Alright, now let's come right down, well, maybe come up away from it. This is nothing but flesh and eroded flesh. It's been really boiled off. Let me see if I can find something that make a little more sense to show that it's flesh. Alright, this takes me back a ways. When I first started, these were all my pictures that I was looking at. Now this, of course, was what we were just looking at a minute ago. But I was looking at all of these different colors, and I could see blood and all that stuff. And then these are all these black blobs in there. And then what is this? I know what it is now. Those are plagial places. And then what about this? What's going on with that? And this. What's going on there? That's a little gold. Some more gold here. This is one of the cavities that they call the bone foramen, and down inside is where the blood and the vein and artery bleed. This is quartz, and I believe that was an artery or a vein, one or the other. See at the round little spot? I believe that's probably the vein, and that's probably the artery. Something like that. Sometimes it's hard to tell. Now this turned into some really serious quartz. Same, well, I think that's the same shot. Now look at this. That's fibrin, which is clotting factor. It's down inside the lung or inside of an artery somewhere. I have a lot of them with the fibrin in them. This just shows the crust around, and inside is where the lung was. This, I don't know what the heck we got going on here. This is, I believe this is the inside of the bone, the marrow, and that's the outside of the bone. The marrow is dense with this heavy-duty black stuff. See, here it is again. That could very well be the marrow. This is just a blob of something. And that is, I believe, when you see this, it's like, you know, coal and blood almost. What did I do? I missed a whole bunch of them. No, there it is. So we got this one. And again, that's, I believe that's what you think is for some form of fossil fuel. Same thing here. That, like I say, I don't know what's that. This has got, obviously there's blood vessels going on in there. That is a mistake, obviously. That, who knows. This is the bone foramen again, and that's the skin, which, whoops, that would, the black stuff there would have been fascia. And now it's transitioned into just black stuff. You see it, but that would have coated everything. And now it's peeled away. And these are little, you know, blood vessels and, you know, skin tissue. All right, these are probably blood cells. See them all collecting around probably an artery. Like I say, I went crazy when I first had it. I believe these are all like blood cells or something. Again, this goes way back. You see these little flippers, these pieces? That's part of the collagen that creates the fascia. This is where I was finding all this fascia stuff, and I'm thinking, well, what the heck's going on with that? And it was all with these little holes inside this fluid-filled highway. You see it? Look at this. Look at this one. I found this stuff really interesting. This one here, I have a better shot of that. It's got actually blood cells down inside there. This is a vein valve. And this is outside edge of a vein area. This is from that lung that I showed you, all the different colors inside the lung. And this is where the blood is inside the lung. That's the lung itself with all the different colored crystals, and that's the blood moving through it. Some more of that stuff. That's just crystal, I don't know what. This is another lung, obviously. Another lung. Black blood. Whoops. You see the black? That's the vein blood, and that's the artery. Here's they crystallize inside the vugs, and this was crystallizing and going to be turned into quartz crystal. And here's another one that's working on it. And this is how the blood settles inside the alveoli. They have all these little branches that go in and out. I mean, I got so much of this stuff, we go on forever. I'm only up to here. This is the edge, see it? That's the edge, and then you get into the meat of the body. This is the wrapping that coats. I believe this is a lung. I can't remember now. But what do we got here? That's that coating again. This is the fascia. All that little fabricy stuff. This is fingerprints, actually. This is the grip skin, that thick layer there. I think I've shown you that before, but I will. You're going to see it because I have that, and it actually separates right along that border there. And I think these are the fingerprints in whatever this was. See it? That's the fingerprints that peel right off of there, which it did here. That's what the grip skin does. There's some more of the same finger. There's some gold coming out of a pore. Some more biology. It's all biology. And I was trying to figure out all these different things at the same time. It was blowing my freaking mind. I mean, I'm telling you, I was just like, duh. You know, that black blood is the vein blood. And the other part would have been where the red blood would have been. You see, there is still some there. You don't have one without the other. They're usually very close to each other. Oh, there's one down here. Look at this. I'm going to leave it at that. There's just so many of them. This, I looked at that and it freaked me out because I know that's an artery. That's an artery, no question whatsoever. That's an artery. What is this thing doing? It almost looks like a plant growing out of here, but I don't know. I don't even know what I did with that. That's scary. When I saw that, I was a little bit freaked out. So that was that one. Hello, hold on. Okay, so again, this is that lung, and I believe that is a blood vessel right there. And that is the lung right here in the microscope. Now, again, that's the alveoli side, and all the flesh just ran off, and these are the lobes of the lung. And the mud is what happens is red flesh turns into actual mud, red mud. All right, now, this is the outside of his lung. You can still see a little bit of red blood here and there. Now, his back, he was laying like this. And this is the top surface, and all that had eroded off and left this runoff. You see it? All right, and eroded all this and left these little, you can see these little swirls, you can actually see them. Where the water just sort of puddled off. Now, this is the inside of his chest. All right, this is where the plumbing goes, and this right here is the backbone. Right there, that's his backbone. Now, if you look real careful, you can see there are still some bits and pieces of bone. That is not natural in mud fossils. The key for this guy is he hit this black layer and was sealed up the bone, and so the bone did not dissolve. Because the bones dissolve, they just dissolve normally. I mean, there are conditions when they don't. But this almost looks like bone, and I'm going to chisel into it a little bit to see. But normally bone, if it's, I showed you one I got around here, so. Normally the bone just turns into mudstone, or some other material. But again, that's the one little spot of bone, and I'm going to show you this in the microscope. All right, now all of this stuff has to be taken into consideration. and we are going to take it into consideration and look at it carefully, because this is a big deal. This is not nothing. Alright, in my last video I've shown this in about a zillion videos, but in the last one I showed this, the hair shaft coming out the top, the erector pili muscle attaching right there, which makes it go up on an end. This is the sebaceous gland right there, you see it? That bulbous looking thing is right there. It slid down the shaft. This is where it comes down to the root. And those two little balls are the vein and artery here at the bottom. Alright, so this comes up through, and the muscle attaches there, and the sebaceous gland has slipped right down here. So this hair follicle, I figured out it's going to be, I thought it was much bigger, but apparently it's only going to be about 35 times bigger than a human being. So if this was human, the guy'd be figured close to 200 feet tall. Now the funny thing is that I have other things from a creature that was probably about 200 feet tall, and I showed this in the last video, which is his fingertip right here, which is, in me, it's 1 inch about approximately from here to here on my fingertip. Now in this one it's 36 inches from here to the very end of the tip of the finger. Now me, it's like 1 inch or so. So I'm going 30 something times bigger than a human being. Now I'm 5'10". So let's just round it off to 6 feet, make it easy. And let's go with 30 times. So 3 6 is 18, 180 feet tall guy. Somewhere around 180, 200 feet tall. Showing this. Now, do I have any more evidence other than this blurry looking picture? That this pad right here is the bone that meets up. It's like a little cartilage to keep the bones separated. Vein and artery. This I broke off. This is the fingernail. That's the fingernail. It's absolutely flawless. And this piece, when I broke that off, it was flawless too. I could not get down to get any blood, so I had to break it off to get inside, and which I did. And here's what happened when I broke it off to get inside, if I can find it. Why does this always happen to me? Here it is. There it is right there. That's just like your fingerprints. These are sweat pores, and that's the fingerprints coming right off. Up here was where the fingernail is, and on us, you too. If you look real close, you're just almost instantly your fingerprints start. Same thing with this, and these are fingerprints. Same, they call them finger ridges. Now, this is a piece that just snapped right off, which is this grip skin, it's called. I couldn't get any blood out of that. There was no place to get any blood. So I had to break it off, and when I did, I smacked it and it just peeled right off, popped right off. And the same thing happened to another one, a giant hand, and that was DNA tested, because I got down inside and it's saturated with blood. You get down inside the fingertips and you got all the blood you can use. And you just get to the artery, just go into the artery. They're very simple to find. There's 2 on the sides and 1 on the end. And the veins have 2 on the sides and 1 on the end. They all have the same stuff. Now, hold on, let me find a picture I want to show you. Alright, I might have shown you this already, but that's okay. This is the grip skin, which is this, which when I whacked it, it just popped right off of this gigantic fingertip. Now I have another one, it's still from a giant, but not quite this size. And here it is, peeling on its own self. I think I showed this. This is the left hand. And you have one of these tendons runs right down your hand too. And then you have a thumb going this way, your little finger goes this way. These are the bumper pads, and that's a cleave in between the 2 pads. This is that grip skin. You see it? This is that real. It just peels right off. Just peels right off. You see it peeling off until you get to the fleshy stuff. The fleshy stuff is just exactly what I showed you before. Now, your palms of your hands, your feet, your fingertips, your fingers and so forth have that skin coating it because it's grip skin, it's traction skin, it's tough. It's almost like having a rubber glove around your hand. And that's why it shows up this way exactly. You see? Keratinized cells. And there's sweat pores in there. This is the epidermis, the outside layer of skin. And then underneath, it's saturated with blood. So there's no problem getting blood out of it, but you can't get it from the surface. You know, I think let's just get started into the microscope stuff. Some of this stuff literally could have been alive yesterday. I mean, it's so perfectly preserved, it's unbelievable. That's fascia and connective tissue and bloody tissue. And this is the coating that surrounds it, the fascia. And that's literally red blood and blood cells. Now, we're going to be looking at this in the microscope, the bone, as much as I can do. This microscope is not bad, but it's not like fabulous either. So we'll see what we can see. Now this, I think, we may look at this again too, because I'm not sure, to be perfectly honest with you, whether these are red blood cells or whether they're fibers, and this is a fiber attachment. This was years and years ago that I did this, so we're going to go through a bunch of stuff. We're going to go through a whole batch of stuff, and you know, a lot of this is going to be looking back at what I thought I knew then and what I think I know now. And do I know now what I didn't know then, or do I didn't know then what I wanted to know now, which I don't know because I didn't know what I didn't know then, because I can't remember what I didn't know then, and I don't even sure what I really know now. Every day, it's another day in crazy land. I mean, this is just crazy. This, I'm telling you right now, that's blood. That's blood from inside of a lung. It's just what it is. And this and that would, these are the blood metals. I mean, this is the red blood. That would turn into, in a different condition, it would have all changed and coagulated into those crystallized forms that you just saw a second ago. These yasmanites, or whatever they call them. Yasganite, tritium, and cassiteratites on hematite. Hematite is the blood, the red blood, the hematite. Whenever you see hematite, that's where iron is from. Iron is red blood. And I tried to make some mud fossils, and I did. This is a mud fossil I made in 3 months or so. It's not great. But after it dried out, maybe 6 months or maybe a year or so, it turned into almost like a belt. But I didn't realize then what I know now, which is had to be boiled and had to be in heavy silicates and some other stuff that I wasn't 100% sure about at that point in time. So I just did another experiment. And it's been going on for about 6 months. We'll find out what happens. But all of this stuff is just unobserved. It's been here, but nobody's paying attention to it because it's kind of spectacular. It is. It's spectacular. And again, it deteriorates fast. That came out of it was just like here. All right? All he saw when he saw us here, and he saw a little something sticking out the edge, and he thought, gee, that's interesting. And when he broke it open a little bit, this stuff came open. He said, wow, that's very interesting. And he kept going, and he got down to the point where there was no denying it was a lung. Now, how long it was in there? Probably since the Great Flood. I don't know. Maybe it was even recent. I have no idea. Very hard to tell. But as long as they stay entombed in the mud, they'll last virtually forever. Like I showed you Phil's heart. I guarantee you that was entombed in the mud during the Great Flood. I would make that claim and feel very confident saying that. And it was because of the boiling hot water literally boiled off the fleshy stuff away from the body. And at the same time boiled the collagens and created what's called feldspar. All right, so it boiled the collagen. What's collagen made out of? Phospholipids. All this is covered with phospholipids. What's phospholipid? It's phosphorus with fats. Well, big deal, Roger. What does that mean? Well, phosphorus is right here. Lipids are just fats. They boil away into the waters and they make everything supple and they work with the chemistry. But what happens with the phosphorus when you boil it? It boils down to aluminum silicates, ALSI. Well, what are aluminum silicates? A feldspar. Virtually everything is coated with feldspar. That's all feldspar. Everything I have here basically is feldspar. It's completely coated with feldspar because that's a collagen. I was going to call it fascia-facilitated fossilization, which means the fascia preserved these organs, like the lung here. All right, that's just absolutely flawless. And that's because of the fascia coated this lung and protected it from being deteriorated. But it had to get boiled, I believe, in these fatty, silica-rich waters with salt and hot and boil and everything boiled away. And again, I think I told you about this before. There's a guy's heart. He had to die flat like that. Boom. With the heart still attached and probably to all the rest of his body. And everything boiled away and the lung became disassociated and the heart went who knows where. All right, and all that is fascia that coats this lung magnificently, I might add. We'll look at that in the microscope in a second. But this is another lung. It's the same thing, only that's the back. All right, and this is just about like that, only this part is boiled away. So what you have in here is the fleshy red, what's left of this, and down into the lobes of the lung and the alveoli. That's all it is. All right, and then I have one here. I showed this before. I've shown all this so many times. I'm sure you're getting bored by now. But this one here is halfway eroded. All right, they attach up here. There's an attachment spot at the top, and there's one on this one too. And then there's one at the bottom that latches in. All right, one at the top. You see that round spot, and one at the bottom. No. And then there's plumbing on the side here. They get flattened out, and you really can't see much. But it's certainly flat. And it died like this. And this got scrubbed away, and that's the pleura, heavy duty stuff, which is still 100% intact on this. Absolutely flawless. And we'll look at this in a microscope, and you see all the little flakes, which are those little plagioclase flakes. I think I showed you before in the upper screen. But we'll be seeing them in the upper screen again anyway. And they are in all of these fabrics that have to expand. All right, that's like a big rubber bag. Doing this all day long, 24 hours a day. And a lot of the stuff in your body does. All kinds of blood vessel activities. So you need something that can roll with that. And all of a sudden you start going real fast, and that stuff has to work with your rhythm of your body. So there's a lot of fabric here, a lot of fabric. All right, here's the deal here. This is the lung that they ran over up on Mars. This is the feet that were going through the dirt. And these bumps were here like this, and with all these little crinkly spots in them, and it just crushed. That's exactly what you see here. You see that? You see the mud right here? This is same, no difference whatsoever. Zero différence. No difference in American English there. Right there, zero différence. All right, it's exactly what it is. Now, why would that fill up with sulfur? Well, I explained it extremely well. It's because of the phosphorus and the phospholipids bumping up to sulfur, becoming pure sulfur inside the alveoli, turning from crystals into full-blown sulfur. And so anyway, they found this huge surprise. Well, I can explain it quite well, and I have lungs in every condition. This one here has eroded. Now this is the guy's whole body, and on the back there's still some bone. You see that? That's a little piece of bone. Bones normally didn't hold up. Now I need to grind these and take a look to see what actually did happen to that. Is there still some bone in there, or is it just now stone that has the exact look of the bone? Because there is a little bit of bone, but you almost never ever find bone in these because they had transitioned in this particular hot water flood. This is the side of the lung, and this is the top where all the alveoli are. Now this is the same thing here. This is a lung here too, but this one didn't erode at all. It's absolutely flawless. That is the fascia, they call it, the pleura. And it coats the lung, and the lung does all this. This is rubbery fabric. This one here has completely eroded even beyond this. There's no mud. This is mud, is the fleshy stuff. All right? There's no mud here at all. All this is down inside. So all of that stuff left, and just left the fabric of a nice lung. And that's where the main entry, and you have all the tubes running through it. It's just nothing more than one gigantic honeycomb. Same thing as this. And that's when it ran over, it crunched. Now, this one here, I have somewhere here. That one has some of both happening. This is all down to the alveoli inside. And this is the pleura has come off. So this is where all the exchange of gases happens inside. And this fabric wraps this thing, and it's like a big rubber bag. Now that's the flat in the bag. The same thing, died flat like a pancake. And this is all what's called feldspar. It's all aluminum silicates. And here on Earth, aluminum silicates is coming down from phosphorus. You see this? Here's phosphorus. Up on Mars, it went up to sulfur, pure sulfur from the phosphorus. Here on Earth, when phosphorus went down to aluminum silicates. That's what feldspar is, and almost every rock there is coated with feldspar. Okay, my friends, in my last video I showed this head as the thumbnail, and I was going to go into all that, but I decided not to do it. Now, what I can show you here is it appears to be, there is a throat here of some sort. Now, this is not available anymore. The guy that had it sold it, and he sold it to a private collector that does not want to have anybody look at it. It disappears. Now, up here, I could tell this is exactly what I would expect from tissue, from the just below the skin tissue. And it looks like something might have happened here. I don't know. But this is basically, that's like the skin peeling off. And the eyes are just stunning. And they do change. The eyes are different than the rest. And you see how there's all this curly looking stuff? That's not unnormal. Now, here's the other part from him. Where is he? Here it is. This was the side shot. And he looks like he's got like 2 or 3 ears. And, facing, this is what we were looking at before. Now, what that is, I don't know, whether that's injury or whatever. Whether he's embedded in some kind of rock, or whether this is, it looks authentic to me. I don't, and this was years ago. That was got to be eight years ago at least. Now, that was from just somebody. Heath sent that to me. Now, I had Heath Bowman. Now, I have another one here, and this one is no question whatsoever in my mind. This is 100% certain for real. This is the head, and it is severed exactly flat here. Now, I understand tissue, and I understand these decompositions, and look at the tissue of the lips, around the eyes, the back of the head is cracked, and it's a red-blooded creature. Here's the back of the head. You see that? That's a crack in the head. And it's red-blooded. And it had like a carapace. And I've searched as much as I can find, and the only one I could find was a white naga. But anyway, this is the guy. That's the head looking here. Here's from a side, looking down at it. She leaves it outside because it freaks her out. I don't blame her. And it absorbs stuff. This is what happens in the mud fossils. You can see the tissues of the face. It must have been like a pink-faced creature. And it has that bonnet, that hood, the carapace. And that looks like it might have had some hair growing out of it or something. Here it is. It's cut flat as a pancake. It's like somebody sawed it off. It looks like to me. And you can see underneath the blood vessels. I'll show you in a minute. But this was a living creature at one time. And these little tiny holes up here look to be like it might have had hair sticking out of there, because that's the only thing I can find that looks close to this. But it did have hair. And that's this thing here. It's a white naga, bestower of fortune. A glycon, white naga. Now, here's why I say I can pretty much assure you this is what it is. This is, first of all, the texture. Just like I showed you that other head. This is what happens in skin. There's a lot of moisture in skin, and it just goes away, and you have these little pits. This is the different stuff in the eyeball, and that's the center of the eye. You can't really dismiss this if you look at it carefully. People didn't make these, and it just didn't form by accident. No, this is the throat. All right, now this, I think it was a serpent. Well, it looks like a serpent to me. Now this is the chin right down here. Now think about this carefully. This is the throat coming up from underneath. Now there's a tongue coming out, and I think it was a forked tongue, this side and this side. All right. Now there's veins and arteries on both sides. And I have a better shot of it. And you see that circle? And that circle right there? I believe, and there's another trunk coming up here of some sort. I believe these are like the vertebra from the head attached to the body. All right, they appear like that to me. I almost fell over. All right, can you see that? Just take your time and look at it. If you have to, stop and come back and look at it. Now I'm going to show you the veins and arteries. Hold on, let me find it. Oh, here it is right here. This is the best shot I got, I think. That red, that's an artery. And that would be the vein. Wherever you see the red is the artery. I think I have a better shot than that. I don't know, this goes back a long time ago. Oh, I guess that's it. That's it right there. The red and the black. And that's right, coming right up the neck. So I mean, it's not. This is not something that's deniable. The damn thing was alive. And look at this. That looks just about like it. Except you can't see the carapace, but boy, I'll tell you, the rest looks pretty damn close. I think people knew a lot more than we give them credit for. And just nobody could talk about these things. So there's this head. And then the other one I showed you is this guy. Yikes. That's scary looking. And you see the same kind of, this all bubbly stuff happens when it's in this kind of a condition. Now this appears to me like it would have died also in the Great Flood. This is what I expect to see from the Great Flood conditions on skin tissues. Now there's other times when the skin turns into mud. These didn't turn into mud. These were in different condition, because I have another one ahead I can show you that is actually turned totally to mud. And this is what happens. Sometimes it depends on where it was. These didn't turn to mud. They turned to other forms of stability. The other one, well, I'll show you. Okay, this is a mud head. It literally is turned to mud. And it is a head, and the nose has been splayed back by somebody stepping on it or whatever. There's blood coming over from here. This is blood, and that's blood. The black and the red. We all know this now. It's not. They didn't realize it back then. Nobody paid attention. And this is. He's got a cap on. Now Jim Burchell and Arlie Caudle found this in Kentucky in a mud bank, and I spoke with Jim Burchell, and they ended up taking it down to University of Texas in Austin to have a CAT scan, and it turned into an absolute nightmare. And that was because Yale University would not accept it unless it was CAT scanned by only somebody they would authorize, and that happened to be University of Texas, and they refused to do it, and I forced it, and it ended up being a nightmare. And there's no question that was alive at one time. Who would carve that? Who would carve that with this smashed in and a cap on its head and his nose knocked over and have blood all in the exact right spots? This is the problem. They refuse to engage with reality. So no matter what you present, it doesn't matter. And I have all kinds of things to present here, all these lungs and so forth. And I understand all of the different processes to create these different types of nucleophilic invasion. Basically, this is mud, and it turned into mud. It was impacted in red, wet mud for a very long time, and it just absorbed that red mud into it. Blood is a different issue. Blood is in with that red mud thinking it's still in flesh. I mean, it still stays bloody. And the same thing with colored stuff. Now, fascia still protects things. This lung was DNA tested, CAT scan, everything. That's from the flood. And I'm sure this was from the flood too. This was not that long ago. All my stuff is from the flood. That's from the flop. And this is another lung. And this is the pleuris eroded here, but that it has actual alveoli right there, but again flat, boiled out of a creature's body. And this is another lung. They're all different conditions. You see this one? There's the lobes of the lung, and this is all the chest has eroded off, and there's still little bits of bones in the back. Little tiny bits of bones are still in here from when he died like that, and all that stuff ran off as muddy clay. That's what the clay is, and all the mud is flesh. And there's another lung that completely eroded out everything out of it, except the scaffolding. So it depends, because sometimes the scaffolding goes right away, sometimes it doesn't. It just depends. The scaffolding's pretty tough. That stuff usually remains. But there's no telling. No telling. And it could turn into glass. It could turn into mud. It could turn into basalt. But they almost all have a coating of feldspar, which is aluminum silicates, and that's because they're involved with membranes. There's membranes on all of these. Everything you have in your body that's surrounded, your muscles, your tendons, your organs, all have membranes. And that's why they separated along these membrane lines. And that's why they have phospholipids, which boil down to aluminum silicates. They're just below it on the periodic table. Phospholipids make the membranes. Aluminum silicates is what it boiled down to. And every single feldspar is made of aluminum silicates. With other different attachments to it. But aluminum silicates is the primary thing because it's a membrane.